Alright, so this is a video that has sound. I'm hoping everybody can hear this, otherwise they make adjustments to make sure that their computer is giving them sound. This is a lesson out of the Chapter 1 study guide on sections 161 and 162. That's Chapter 1, Section 6, Part 1, and Chapter 1, Section 6, Part 2. So, I'm actually going to do this kind of all together. I'm going to cover both 161 and 162 together in this video. I think, let me just check the examples here. Yep. Okay, so we're going to start actually with a kind of a long page of definitions here. We don't usually need a lot of definitions, but Section 161 is really just all on knowing what all these words mean. So it's going to be really important that you be able to correctly know all of these words in order to pass this quiz. So, a polygon is basically a shape. Now, it is a closed shape, which means that when you draw it, it doesn't have an open end. So that's an open shape. Once you draw the final side on there, then it's a closed shape. So a polygon is a closed plane figure, meaning that you can draw it on a flat surface that has the following characteristics. It has 3 or more sides. Each side touches 2 other sides. And you can see, for example, this side touches these 2 sides. And the sides are line segments. Now, this last one's really important because you can't have a polygon with curvy parts. So, for example, this is not a polygon because do you see that curved portion on the top? That's what makes it not a polygon. All the sides have to be line segments. That means they all have to be straight little portions of lines. Okay? Line segments. So, this would not be a polygon. Again, because of the curved parts. This one would, triangles, squares, kite shapes, pretty much anything that has 3 more sides where all the sides are straight and they come back around together to close themselves off as you draw them around. That's a polygon. Sides, I think you know what sides are. Side, 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 side. Basically, with polygons, they're going to be line segments. The vertex is the endpoint of a side. When 2 sides come together. So what exactly does that mean? A vertex is basically the pointy part. So if this is my polygon, you see how it has 5 points on it? 1, 2, 3, 4, 5. Each one of these corners, basically, is the vertex. There's a vertex here, 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 and here. So you just want to think of a vertex being a corner. It's a good way to think about it. Convex. Okay. Convex is a polygon on which all the vertices, or each corner, they all point outward. Okay, so this pentagon that I drew, you can see all these corners are pointing out from the inside of the shape. That would be a convex polygon. Most of the shapes that you're familiar with are convex. Triangles that you've seen are convex. Rectangles and squares are convex shapes. All the corners are pointing outward. Now, concave is probably a new concept to you. A concave is a polygon on which some of the vertices, some of the corners, point inward. Now, it can be just one, or it can be more than one. So here's an example of a concave polygon. See that? That point is pointing towards the inside of the shape. That's what makes it concave. Now, some students like to ask me about the names of things. So what I'm going to do, I'm actually running out of space at the end of my packet, so let's see how much space I have. Okay. What I'm going to do is I'm going to go to the end of my packet. There's extra pages of notes at the end of your packet, so I'm just going to flip back here. And I'm going to go over the names of all of the different types of polygons. So based on the number of sides, many of these polygons have specific names. So a three-sided polygon is called a triangle. A four-sided polygon is called a quadrilateral. A five-sided polygon is a pentagon. A six-sided polygon is called a hexagon. I remember this one because the word six has an X in it, and the word hexagon also has an X in it. Seven-sided shape is called a, heptagon. That's supposed to be an H there. An eight-sided shape, most of you know this one, it is a octagon. A nine-sided shape is called a nonagon. And a 10-sided shape is called a decagon. Now beyond that, yes, there are names. If you go online and you Google, names for polygons, it'll give you tons and tons of names. But usually, it's really not a skill or a knowledge set that's important to have, not to be able to, know what the name of a 15-sided polygon is. It's okay if you don't know that. So a lot of times we just call it, once we get over 10, by a kind of easier way. So if you want to call something a 15-sided polygon, we just call it a 15-gon, like that. Or a 22-sided shape, we call it a 22-gon. So you could say it's a 100-gon. Sounds like somebody stole your wallet, right? But anyway, this is an alternate way of naming things, as I said, once we get over 10, and it's called the n-gon method of naming, where n is the number of sides. Okay, so you won't have to know these names always, but on this quiz you'll have to recognize them, and hopefully you know most of them, so the rest of it won't be too much to learn. Okay, so right now I'm going to go back to the page we're working on with the definitions. I just gave you the definition for an n-gon. It's a shorthand way of naming a side that has more than 10 sides. Okay, so the last three are really, really, really important. So please make sure that you learn these. Equilateral. Equal means same. and lateral means side. So an equilateral polygon is a polygon where all sides are the same length. So an example of an equilateral polygon might be a rhombus, I try to draw this so that this side and this side and this side and this side are all the same length. Might pull it a little bit more over here, but anyway. Squares are equilateral. If you draw a perfect triangle, like that, where all sides are the same. Okay, those are examples of equilateral shapes. Equiangular, again, equa means same or equal, and angular means angle. So an equiangular shape could be a polygon, or is a polygon, where all the angles are the same. Okay, so this is different from equilateral because you could have a shape that has different side lengths, but the angles are the same. For example, a rectangle. On a rectangle, all the angles are 90 degrees, aren't they? But it doesn't necessarily mean that all the sides are the same. You could have the sides that are the same as well. You could have it a square. So a square, it turns out, is both equiangular and equilateral because it has both things going on at the same time. It's got all four sides that match and all corners that match. So it turns out that this idea here has a name. When you put together the concepts of equilateral and equiangular, if you have a shape, if you have a polygon that is both equiangular or equilateral and equiangular, that means you can call that shape regular. So it turns out this shape right here, all three corners match and all three sides match. This one is regular. This is a regular triangle. And this one is a regular quadrilateral. We call that a square. You could try to draw a perfectly shaped pentagon. It's not the easiest thing to do, where all sides are the same length and all angles are the same amount. Okay, so remember, these definitions on this page are very, very important. So if you haven't been able to get all of them down, I suggest backing up the video, and then if you need more time, just pause to make sure you get all of these ideas, because they're very, very important to passing this quiz. Okay, moving on to the next page. This is just a kind of a rehashing of the definitions that we went over on the first page, so I'm not going to do that. So let's start with example 1. Tell whether the figure is a polygon. Well, remember how I said that any side has to be connected to two sides? So do you see this side right here? It's got 3 connections. It connects with this one, and this one, and this one. That's what makes this not a polygon, because you'd have to have every corner only connecting with one other side, or you could say one side connecting with only 2 other sides. So this one is not a polygon. Since it's not a polygon, I'm not going to call it convex or concave. I'm just going to say that it's not one. B, is that a polygon? Well, does each corner simply match up two sides? Yes. So that each side has two sides that it's touching? Yes. Does it have a closed, is it a closed drawing? So that when you go all the way around, it goes back here and there's no, it's not hanging open, like that. This is an open figure. Okay, that's not going to be a polygon. So yeah, it's closed. It's got three or more sides. Each side touches two sides, and each side is a line segment. Yeah, this shape follows all those characteristics. So this one is a polygon. Now, is it convex or concave? Well, convex means that all of the corners point outward from the center of the shape. And concave means there's at least one or more corner that points in. Well, this to me is a convex polygon because all the corners point out. Is this a polygon? Is it a closed shape? Yes. There's no gaps in the shape. Does each side intersect with only two other sides? Yes. And are all the sides line segments? Meaning, are they straight sides, not curvy sides? Yes. So, this is a polygon. Is it concave or convex? Well, convex means that all the corners, all of the vertex points, point outward. Concave means there's one or more of the corners, the vertices, that point inward. Well, I see that this one points inward. Do you see that? This little corner points in towards the center of the shape. So it couldn't be convex. It's concave. So if you think of the word concave like a cave-in, like something caved in, that's concave. Okay, so let's move on to some other definitions. We just talked about what a polygon is and what convex and concave means. Now let's move on to equilateral, equiangular, and regular. So, is this polygon equilateral? Are all the sides the same? Well, these tick marks here are indicating that. Whenever you see a tick mark, that means it matches the side marked with the same tick mark, and they're all marked the same, these sides. So I would say, yes, this polygon is equilateral. Is it equiangular? Well, each one of these little curved markings are trying to tell you that each one of these angles matches all of the other ones. So, yes, it is also equiangular. Now, regular means that both of these things have to be true. It has to be equilateral, and equiangular. So, since we said yes to the first two qualifications, then it must be a regular shape as well. Classify the polygon by the number of sides. Well, let's go back and do that up here. How many sides do we have? 1, 2, 3, 4, 5, 6, 7, 8. So this would be an octagon. How about this one? Well, this would be a quadrilateral. Is it equilateral? Are all four sides the same length? No. These two are the same as each other, but not all four. So that'd be no. Is it equiangular? Are all the angles inside matching each other? These two match each other and those two match each other, but not all four of them are the same. So no. And so, in order for it to be regular, both of these things have to be true. Neither one of them are true, so no, it's not regular. Example number 3. Now here we're using some algebra to find our answers. If we have a regular hexagon, hexagon means it has 6 sides, right? Remember the x in hexagon is like the x in 6. And then regular means that all the sides are the same. So this side matches that side, which matches this side, which matches that side. All the sides are the same measure. So that means that this length up here, 4x plus 3, must be the same amount as this length over here, 5x minus 1, because this side would have to match that side since the shape is regular. So they want me to find the length of a side. Okay, what do I know about these sides? I know that they are the same length. When things are the same in math, we can say that they're equal. And when we know they're equal, we can make something called an equation. This side must be the same as this side. I know they're named a little differently, but they actually represent the same amount. You'll see. So I'm going to solve this equation. And I find that x equals 4. So if these two sides are the same length, it doesn't actually matter which one we use to find our answer. I'm going to do both just to show you that we get the same exact answer. So if the x value is 4, this would be 5 times 4 minus 1, which is 20 minus 1, or 19 millimeters per side. Now since these sides are actually the same amount, this should also be 19. If we take 4 times 4 and add 3, we get 16 plus 3. Oh, sure enough, we get also 19. When things are equal, it doesn't matter if they're named a little bit differently. We know that they should ultimately, once you find your x value and substitute it in, end up giving you the same answer. So the word congruent is a fancy word for meaning the same, or the exact same measure. So the last example is talking about how two angles are congruent. That means that 4x plus 8 is the same measure as 5x minus 5. Just as we did up here, we can say that they are equal amounts. So if I subtract 4x on both sides, and then add 5 on both sides, I get x equals 13. So if we want to find the measure of the angle, since these two are the same amount, it doesn't matter which one we substitute in to. We know that our x value is now known, and it is 13. So we multiply 4 times 13, which gives me 52. If I add 8 to that, I get 60. Now, since these two amounts are representing the same thing, we could have just as easily chosen the other algebraic expression, but we should get the same answer. These two things are the same. If we multiply 5 times 13 and then subtract 5, we would get 65 minus 5, or same answer, 60. They are the same for this value of x. We just had to find it first.